Whoa! Didn't see you there. What, are we rolling? Whoa! You must be thinking, wow, Mr. Burger. Dr. Burger. Oh, I know myself, of course. Wow, Dr. Burger. What's with the big afro? Well, I was just working on some cool mathematics. I just looked at myself in the mirror and I was like, wow, you're looking nice. So, I just happened to keep it, you know what I'm saying? So anyway, now we're about to start something that really is exciting. We spent a lot of time really computing knowledge, really toiling and computing derivatives and various applications, really seeing how they work and really working hard and like doing so. So what we're going to do today is look at the start of differential equations and related rates. And now let's see. Whoa. Well, I was just climbing a ladder and then suddenly it just slipped out from under me. Whoa, I was just practicing my facial expressions as well. Oops. Hope it wasn't too scarring. Anyway, I got a little excited with calculus. Sometimes I get a little excited with calculus sometimes. Anyway, it's good that I was doing that since it actually reminds me of this related race problem where I fall off a ladder. What coincidence, right? Not in real life, luckily. Whew. Anyway, let's take a look at this problem together. See how this ladder slips. Alright, so 14-foot ladder is leaning against a wall. If the top of the ladder slips down the wall at a rate of 2 feet per second, how fast will the end be moving away from the wall when the top is 6 feet above the ground? Alright. Well, first, we have to ask ourselves, how are rates related? Okay, so we know the length of the ladder and when we need to find the rate. So using our triangle right here, and then just fill in stuff we know. So we basically know that the ladder is 14 feet long, and we want to figure out when the rate at which when the ladder is falling when this is 6 feet. So then this distance here we have to figure out, and it's easily figured outable through the Pythagorean theorem. So we know that the hypotenuse is 14 squared, and we know that one of the legs is 6 squared. So then we add our mystery number, which we'll just call x. And then, so we do this, and then basically x works out to be 4 root 10. Okay, so then we just put that here on our handy dandy triangle, 4 root 10. Okay, so now what do we do? Well, this is a fun part. We get to do some implicit differentiation. Okay, so let's just call our 6 squared, let's call that y. And then we'll call that L. So then we have y squared plus x squared equals L squared. Okay, so now we have to do some implicit differentiation. So like our chain rule, we do our normal derivative thing. We do, okay, y squared, that's easy, 2y. And then the derivative of the inside we'll call dy over dt. And that's just the same for x squared. So that just turns into 2x times dx over dt. And then the same thing. Wow, it's so easy. 2l times dl over dt. Okay, now what? Well, now we just plug in what we know. Okay, so we go back over here. Okay, our x is, this is x, and okay, this is y, this is L. Alright, so then we plug in our y, which is 2 times 6 feet times which is, and then the rate at which it's falling is -2, which is given. Okay, and then we do 2 times 4 root 10, and then this is the rate we want to solve for. So dx over dt equals 2 times the length of the ladder, 14, times our rate, which is the ladder doesn't change, so that's 0. Okay, so then we work this out. 2 times 6 is 12. 12 times -2, -24, plus, okay, 8 root 10 times dx over dt, and then all this times 0, so then that's just 0. And then now we're left with this. So then we do 8 root 10 dx dt equals 24. Okay, now let's divide it. Divide by 8 root 10, divide by 8 root 10, and then we have solid dx over dt equals 24 over 8 root 10 equals, divide that by 8, it's 3, divide that by 8. Got a nice 3 over root 10. That is our answer. 3 root 10. Don't forget units, because don't want to lose that point on the AP test. So that's your nice feet per second. And there you have it, boys. That's how you do your related rates. So now we're gonna turn it over to Professor Sushi, and he's gonna show us a different example on related rates.
Hey guys, Professor Hot Dog here. Now we're gonna do a different example with rates that are related by a different formula. So let's jump right in.
So here we can see that the radius is 1 divided by 20, 3 plus h squared. So we can just write that right here. And then when the height of the liquid is 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1.5 inches per second. So basically what this question is asking us is just to find the change of the height of the liquid with respect to time. So basically that's just dH over dt. Alright, so all we have to do is find our information. So we know that h is going to equal 3 and dr over dt is going to equal -1.5 inches per second. So the next thing we gotta do is find all the relationships between the variables and the rates. So we know that the radius is equal to 1 over 20, 3 plus h squared. So now that we see that, all we gotta do is take the derivative of both sides so we can get the change of the height of the radius with respect to time. So here, see here, this is a little hard to find the derivative of because we gotta do the chain rule. We gotta find the derivative of the outside function times the derivative of the inside function, which would end up being 1 over 20 dH over dt times, well, 2h. And there we go. dr over dt equals this. So now that we've found the derivative, all we have to do is plug in all of our variables. So what is dr over dt? -1/5 inches per second is equal to 1 over 20, and then dH over dt, that's the variable we're trying to find, times 2, and then our height is 3. Whoop-de-doo, we did all the calculus in this problem. So now, assuming you took algebra, this problem should be a breeze. So we can rewrite this as 6 over 20 dH over dt Divide both sides by 6 over 20. And we get negative 2030 equals dH over dt. But we can simplify that to negative 2/3. There's our answer, peeps. Woohoo! Yeah.
That is related rates in 10 minutes. Go back, think about it, have fun with it, get that 5 on the AP test. And one more thing, don't forget to like and subscribe.